Hi guys, and welcome to today's video. So here we're doing a linked list implementation, but you probably already knew that from the title of this video. Anyway, so we are going to create our linked lists using classes instead of structures, and we'll have a class that will represent each node, and we will also have a class that will represent the linked list itself. And this node here, the class of the node, will basically have data that will be an integer, and it will also have a pointer to another node which will represent the next node. So if we come, actually not here, but let's make it on top. Let's make a multi-line comment. Now let's do this, this. I don't know. Let's just make it simple. Okay, let's start that. So this whole thing will be a node. This is a node, and this node will point. Let me see if I can comment only that out. Whatever, let's just copy that, paste it, and we can paste it here. Yeah, okay, whatever. So I'm going to manually do it, but I can copy that out, I'm sure. Come on. So let's paste it here. Yep. And then let's paste that here, and then finally let's add that. Now, okay, let's add here, let's add that there as well. Oops, and then let's add that. Okay, cool. Now this would be just a normal node, and this will still be a normal node. However, not only is going to be normal, but it is also going to be the next. So let me lowercase that. So this node is the next of that one. So that's what this next will represent. And this here node here points to that pointer, points to that node. That's why we have this pointer in there. Now let's implement that. We'll just say class node int data and node pointer next, which is the same thing we did here. So we've got our pointer, we got our node. I think for now that will be everything that we need in our node class. Now let's go and implement the linked list class. Linked list, and what is our linked list gonna have? Our linked list is going to have a head, and it also is going to have a tail. Now for this example here, I'm actually going to open Paint. And what do I mean by head and tail? So let's get this here. Oops, that's too big actually. Make it like this. I hope this drawing will do. So now let's say this is one, this is head, and this is tail. So basically what you can see from here is that head represents the node that points to the first node, and tail is the last node that points to no. And actually here I said that head points to the first element, but actually I'm not going to implement it that way. I'm going to implement it as head being the first element. So that will be 1, that would be 2, that would be 3. And what I did here, this is that basically means that it points to nowhere. That points to no. That means this is the end. This is the end of our node, of our linked list, meaning the tail represents the last node within our linked list. Okay. Now let's go back here, type that, and just like next in here, this is going to be a pointer again, because it points to somewhere. In this case, head points to 2, and this is a node of type node, so we need a pointer, it points to there. And tail, even though it's not pointing here to anywhere, it actually points to no, right? So it's still pointing somewhere, so it needs to be a pointer. Now, our API will basically contain void add. So this basically, I don't need to comment that out. So this basically adds an element to the actually I'm not going to call it that, I'm going to call it push, because this will be adding an element at the end of the linked list. Then we'll have size. Let's have size, and size will return the number of elements or the number of nodes in the linked list. Push, and then we'll also have insert, and this will be a bit tricky one to implement. This will be int file and int position, and this means that we'll insert that value here at this position. And lastly, we'll have a print function that will just basically print all of the nodes within the linked list. Okay, so now that we've got all of this, let's what are you complaining here? Comment unclose at the end of the file. Alright, whatever. I'll take that. Let me just do it like this. Okay. Now let's come and actually implement these. So I'll just control dot on it. I think that's the one. Yep. Just Visual Studio making that easier for me. Control, and if you want to know how I do that, as you can see here, it says control plus dot or alt plus enter, but I do control dot, and then you just enter that, close that, control dot, do this, close that out. And basically what we did was creating all of these methods here. So okay, I don't want that for now. Okay, now what will be our push method? Now let's come back to Paint and let's make a new one. I don't want to save that. Now let's say we've got this linked list here. So this will be 1. Let's have another one. That will be 2. I can have that there. Then I'll have 3. And let's leave that there. Right. This will point to nowhere for now. And again, let's go with our previous example, which would mean this would be the head and this would be the tail, just so it's more clear. Now when we say, let's say push, when we call this method push and say for, we need to make that tail, instead of pointing to nowhere, we want to make it point to 4 or to the last element. So what I'll do is, let's change the color, have that 4 here, there we are, and now this 4 will point to nowhere, as this will become the new tail, and now this is not tail anymore, and instead of pointing to no again, this will point to 4. There we go. So this now will become the new tail. So that's what we need to do with that one. Okay, so let's try to do it. First, what we want to do is check if the linked list is empty, because if there are no elements, we want to make the head, right? We want to make the head to be equal to whatever has been pushed. So how do we do that? Well, actually, let's create another function that will be bool is empty. Now let's create that. Actually, I'm just going to control dot it because I'm lazy. Close that one and there we go. Come here and okay. So what do we want to do here? We'll say if this will represent the linked list that we're calling this method on. So if this head equals no, right? Equals no. Come on. I don't know why that doesn't work in Visual Studio. Anyway, if this head is no, right? Meaning, if this head doesn't contain any elements, meaning that there are no elements after that as well, then we will return true. Otherwise, we return false. Right? Yeah, I think that's good. Now, let's come here and say if this is empty. So if it's okay, let's make it if that's not empty, or if that's empty. Actually, that's what I'll do. We'll say this dot head, and before doing that, I want to create a new temporary node, which will be node new node. I'll just call it node, and we'll say new node. Now here what we want actually our what we want our API in our node class to have is a constructor, which we forgot to write, which would be public. Actually, I'm just going to make everything public, so we can just get these variables nice and easy. There we are. Now let's create our constructor, which would be node, and then let's make it an initializer list that will say data, and here it will take int, which will be a value, and we'll say that this data will be equal to this val. And we also want to make this next here automatically point to no when we call this compiler here. Now, let's not forget our curly brace here. So that's our constructor here. Now let's come back here. Now when we create this node here, what we basically say is create a node, right, that has a value. In this case it will have value 4, but when we first create it, we don't want it to point anywhere, and that's what we do here. Don't make it point anywhere when we first create that. And then what we want to do is this head, we want to make it equal to node, but before that we need to make node to be equal to this head. Actually that would be the other way around, right? Yep. So let's check if that worked. So we'll come in, actually what we can do is cout this head data. So now this node has data, right? Because we're making it here in our constructor in here. Now this should contain 4, And since we're making this head equal to this node, and so we're making it equal to this. Actually, I don't need that line, do I? I'm just making the head equal to that node, and then I want to print the data, which should give us back 4, because this value here will contain 4. Now let's create a linked list instance. Those say just list 1, because we may have more. This needs to be a pointer because we're using the new keyword, new linked list, and that will be it. Oh, okay. Now in our linked list, we also want to have a constructor which will be linked list, and before doing that, I need to make everything public as well. Forgot that. Linked list is not going to take any parameters. However, what we want to do is say head, make it no, and tail, make it no. On when we create our linked list instances, we want to have the head set to no and tail set to no. And then just say list 1 dot, not dot, but push, and we need to set a value 4. There we are. Now this, when we run that program, it should return us 4. If it doesn't, then that means there is something wrong in here. Now let's save that. Click on local Windows debugger, and we've got an error, which is sign must return a value. Okay, so we just say return 1. Okay, let's rerun that. And no error. Okay, great. So it's given us 4. That means that we successfully made our head equal to 4, or to whatever the node value was. Now, what we also want to do is, since this is empty, we also want to say this tail equal to node, because in this case, both the head, so basically that node will basically be both the beginning and the end. So that will be the tail as well. So what we say here is this tail equal to node. Alright, that's if our list is empty. So that's what we're having right now. Now, if we call list 1 push 5, right? We want to make that, instead of pointing to nowhere, we want to make it point to 5, and make 5 point to nowhere. So how do we do that? Well, since our list won't be empty anymore, we want to say, so we've got our node here, which will represent 5, and we want to make since we'll be iterating to the linked list, we want to create node pointer that will be equal to the head of the list. Now the reason we want that is because we'll be iterating through the linked list. So now what I'm going to say is while pointer next is not equal to no. So basically what we're saying is we're starting from the head, from here in this case, and we'll be looping until the next pointer is not no, and in this case it will be 5. Okay, our pointer next is not no. Actually, I think what we want to do is have just the pointer, because here we'll start from head, then we'll go to that one, while pointer we want to move to the next one, right? Okay, let's see. All right, yeah. Anyway, so while pointer is not no, and that means that this here is not no, right? So we'll move, since it's not no, we'll move to the next one. But actually what we want to say is next. So if the next is not no, which it will be, this won't run in this case. But we will need that when we have more elements in our linked list. For now it won't run. So what we're saying there is, let me think. Then we're saying pointer dot pointer. Okay, that's pointer here, right? That's pointer, which is pointing to no. We want to make that point to the new node. So how would we do that? Well, we'll say pointer next equal to node, and this node is the new node that we've created, which in this case will be 5. Now this should point to 5 instead of 0. And what do we want to make it also? We want to make tail equal to node, because now this is our last element in the linked list, which means it needs to be the tail, right? Now, I'm not sure if that's really working. Now, let's go into our print and create that so we can be debugging throughout our implementation. So what we'll say is node pointer will be equal to this head, and then we'll just be looping while pointer is not equal to no. We want to see out that. See out pointer dot data, and we also want to move the pointer to the next one so we don't run into infinite loop. There we go. Now let's save that and let's call that function over here. List1 dot push, not push, but print, right? Save, run. We should see 4 and 5. Okay, yeah, great. So that means that this is running. Now to check it more thoroughly, we'll add another element. So let's see if we didn't somehow hard code it just for this particular case. So now let's say we want to make that point to another element, which we'll call 6. Now what we should see is 4, 5, 6 in the console of the print function. Run that. 4, 5, 6. Great. So let's go through it again. What are we saying? Well, here we're saying while pointer next is not no. That means we're starting from head, and in this case, when we're adding 6, pointer next is not no because previously we have created the pointer from the head, so the head next to be equal to this 5 here, right? The previous iterations, we made that be equal to 5. Where? Well, from here. Then we made that as a tail, and then the next time when we add this 6, we are saying go to pointer next is not no. So again, we are going the first time. So pointer next is not no because pointer next of the head is 5. So then the next loop, the next iteration of the loop in here, we're going to 5, and is pointer next of 5, meaning is it pointing to somewhere yet? Well, it's not. That means we'll exit out of that loop, and when we exit from that loop, we will have arrived to 5, to here, and then when we have exited from that loop and we came to 5, we are making 5 point to the new node that we've created here, which is 6, and we're making it point to there. So that means 5 now points to 6, and we're making the tail to be equal to this new node that we've created. So that means the tail now is in here, not in here. So let's delete this here now. So that's our final look, our structure, our final structure of the linked list that we have. That's the one. Alright, so that's our push function. Hope that makes sense. Let's delete this. Let's make it a bit more clear. There we go. Now let's do the size. There are many ways that we can do the size. We can even have it in our push function. Every time we push something to the list, we increment a counter with 1. But in this case, we're just gonna make it here. And I'm going to initialize the counter variable that will be incrementing every single element that we come across. And then we'll have, again, making the node, which will be pointer, and which would be equal to this head, because we'll be looping. And we'll say while pointer is not equal to null. There we go. What do we want to do? Well, we want to counter plus plus, and then don't forget that we want to move the pointer to the next. So again, we don't run into infinite loop. And then what we're saying is return the counter. There we are. What we could say is if pointer is equal to null, meaning if the list is empty, what actually we could do is, since we already have this, we could say if pointer dot not pointer but this is empty, return. What do we want to return? Well, we want to return 0 since it's empty, right? So we just have a nice little base case here. Let's put that there, base case. And now we are returning the counter. So that's our size. Now let's see if it works actually. Now let's say list1, give me the size of it, right? But since we are returning it, we need to actually print that out, see out it. Oops, not that one. Just like that. Now let's run that. You're gonna see an error here. Non-standard syntax. Use, oh, yep, okay. We didn't call that function. We just say it's empty. And we've got another error, which is counter. Okay. Uninitialized local variable. Okay. So we need to make it equal to 0 because it wasn't initialized. There we are. Okay, so that represents the size. And since we've got 3 elements, that returns 3, which is perfect. So it works. Now let's delete that, we don't need that. So the last thing we want to write, the last piece of our API is insert, which will be the hardest part we'll be writing in this tutorial, because we have to keep track of many nodes. Now let's create a new drawing here. Now let's say this will be the head. There we are. This will point to 1, to 2 actually, this will be 1, 2 will point to 3, 3 will point to 4, let's make the full screen, and finally let's make 4 point to 5, and 5 will not point anywhere. So this will be the tail. Right. Now, what we want to do is call this function, which is, where is it? Yeah, which is insert val position. So let's make insert. The value we want to insert is 6, and we want to put it in which position? Well, let's make it the second position. Now, let me change the color. The positions that our linked list will have will be 0, 1, 2, 3, 4, just like in arrays. And we want to put a new node that has a value of 6. So that means what? Well, we want to put it in here. So that means that we want this node to not point to 3, but rather point to 6. Right? Because that's where we are putting that. That's what this function should do. And then we want to 6 point back to 3. Just like that. So then that's the final look of the structure of the linked list. And so it's a bit tricky now because there are many ways that we can implement that. So the one I'm thinking of right now is we can have two nodes. One will represent the current node, and another will represent the previous node. So then, let's say we arrive at the node that we need to change the position of it. Let's say 3. So this will be the current node, and we'll be keeping track of the previous node. So this will be the previous node. So when we come here, what we want to say is make the previous node point to the new node and make the new node point to the current node. So let's make that. So let's come here. First, what do we want to do? Well, we need to create a previous node. We also want to create a current node. And let's make that now actually. So what do we want to do? Well, let's say we want to create a node. That would be just previous. Let's not initialize it for now. Now let's create our current. And then what we want to also do is create another node that will represent the new node that we're adding. So let's keep it node, new, node, val. That's the new node. There we go. Okay, now, how can we make a previous node and a current node? So let's make the node current to equal to the head, meaning the first element. Now, this will be the current. Then we'll make it be equal to the next element, which will be 2. And when we make that current element be equal to 2, we will make the previous node to be equal to the current. Okay, I'll show you what I mean. We'll say current. Alright, so while current next is not equal to no and minus position, that means we will increment, we'll be looping while we haven't reached the end of the list, right? And we are still having to increment the position. Basically, if it was, let's say, if it's 3, if the position, if the position is 2, then we'll be looping 2 times, because first the position will be 2, then it will be 1, and that's it. That's the only times it will be incrementing. So that means this will have to loop. We have to increment. It will have to run 2 times, considering the fact that this will be also true. So if one of these things is no longer true, then it won't run anymore. Hope that makes sense. So what we wanted to do is create a previous node, right? Create a previous, to be equal to the current, and then we want to make the current go to the next one, point to the next one. So what we did here is we made previous equal to current in the current stage it is in. So first, current is the head, right? This head, that's where the current is. That's where we initialized where it is, yeah, here. So then we are making the previous be equal to that. However, after that we immediately say current go to the next. So then current will be equal to 2. And in the end, what is it? Well, previous is every single loop one place behind. So again, in this case, this head will be equal to 1. And it will, and that's how it should be every single time in the end of the loop. Previous will be 1 node behind. So now what we can do here is, let's go back to our drawing here. So what do we want to do? Well, we want to make the previous here, we want to make the previous point to the new node. So let's do it. Prev, yes, next, right? Make it point to the new node. Then we want to make the node, the new node actually, point to the current element. And that's it, I think. Yeah, that's current. Now this should work on theory. I hope we're not forgetting something. Now let's try it. Let's come here and say list 1, insert. Let's insert 7. At which position do we want to insert it? Well, let's insert it at first position. So now, what should our linked list look like when we execute that? It should look like 4, 7, and then 5 and 6. That's what our program should print when we run that. Oh, but we're not. Oh, okay, we got a problem somewhere. Yeah, I was wondering how we should make the previous. Maybe if I make it just equal the head. Using an initialized memory. Yeah, we're now initializing it here though. There we go. Now, if we run that, let's see. 4, 5, 6. Yeah, because we didn't print it. That's what we forgot. There we go. Let's save that, run it. Yeah, we're getting an infinite loop. Let's see why that is. Where's the infinite loop though? Is it here? Is it here? Let's run it. Can we stop that? Okay, now 4, 5, 6, and then 4, 7, 4, 7, 4, 7, 4, 7, 4, 7. That's what we're getting. So that means that here we're not doing something correctly. So to debug that, let's comment that out and let's see out both of these elements. So let's say see out previous and line, and then let's also see out the current, just so we can see that they are the correct elements. So I'm going to delete that line there, and we're also going to say previous, yep. And we want to say previous data. so we can actually see the data in it. And in here, what we want to say is current, and we also want to print the data. There we are. Let's run that. Now, before we run it, let's see, what do we want our previous to be? Well, we've got 4, 5, 6. We've got 4, 5, and 6. So, let me change the color. So 4, 5, 6. In that case, I'm a bit confused right now. Current next is not no. Previous will be current. So okay. How many times is this going to run? It's going to run 2 times. So 1, 2. So that should be current, and that should be previous. Or should it be the other? Should that be current and that be previous? You know what? Let's just run it and see what's actually happening. Control S, run. Previous, okay. So we've got previous to before and current to before, which means that previous is not actually previous, is it? So we want to make that no. Now let's rerun that. Okay, so now it's no pointer, yeah. But it shouldn't be, because here we're setting it. Is this even running actually? See out running? I think that's where the problem is. This loop isn't actually running at all. Yeah, it's not running. Okay. So what might the problem be in here? So let's... Problem might be that this shouldn't be next. Should be current. Now shouldn't that... Well, current is not no, and minus minus position. Oh yeah, okay, never mind. Why are you doing that? Read access violation, because it is no pointer. Come on. Yeah, so why is that not running? Not current. It's not no. That doesn't make sense. Now current is a problem. What? Current data. I don't understand why that's not running, to be honest. really don't. See, that's no. Why is it no? We're really doing the same thing as here, aren't we? Well, pointer next is not equal to no. Yeah, same thing here. Here's not running. Node current this head Wait, so now that's not a problem, is it? If we run that. Yeah, so now it's not a problem. How interesting. Okay. So let's make this in position minus minus. Let's run that now. Current is 4. So let's remove that next because we don't need it originally. So let's run that now. So we should see 4. Why? Oh, okay, because we're seeing 1 here. Okay, I thought this whole time we were saying 2. Alright, so now this should give us 5. If we run that, current should be 5. There we go, okay. So, let's uncomment that now. Let's try to make that work. Just like that. Now let's make previous uncommented. And what previous should be is 4. Okay, great. So we've got that. Now if we make this 3, right, we should get 4, 5, 6. Actually, there are not enough elements to do that. So in this case, I'm going to add more. 7, 8, 9. Now if we make that at the 3rd position, that would mean that 4, 5, 6, 1, 2, 3. So current would be 6, previous would be 5, right? I think that's correct. Current 6, previous 5. There we go. If we make that 4, I'm just making that so you guys can understand it as well. We're getting 6 and 7 as current and previous. Okay, that's great. Now let's actually try that again here. See if that's going to work. If we come here, what should be able to see? Let's not make that 7, just let's make that something else, like 33, so we can easily differentiate it from the others. So we would put that in the 4th position. Now let's draw that. So we've got 4 goes to 5. Oops, 5. Actually, I'm just gonna make 6, 7, 8, 9. That's the list. When we insert 33, so by the way, this is 0, 1, 2, 3, 4, 5 position, and 33 should be inserted at this position. Yeah, that means that the new list will look like 4, 5, 6, 7, 33, 8, 5. That's the new list that we should see. Let's run that. Let's see if that's what we're getting. And we're not getting that. Oh, yeah. We actually... Oh, are we? I think we're not quite there yet. We're getting 4, 5, 6. We have 33 in before 7. Yeah, and that should be 9, by the way. 7, 8, 9. Okay. So we are almost there, but we're seeing something. So, what does that mean? We need to fix that. That's the logic that we need to fix. So if we go back to where we did the drawing for the previous and current, which is that one, is previous next should point to the new node, which we are doing. Then the new node should point to the current one. Interesting. What I want to do is, come on, seriously, previous. I want to see actually what exactly is the previous value. We've got an error somewhere, or no, we've got, okay, that's fine. So previous is 6, but should it be 6? So even if it is 6, we are making, okay, if let's say it is 6, let's see if our logic in the first place is correct. So we're making 6 point to 33, which is that if we come here, so let's pretend that this is our previous one, which is 6. So we make 6 point to the new one, which in our case is 33. So yeah, we're making 6 point to the next one, which is 33. And then we are making 33, which is the new node, in this case it's 6 here, point to the current one. And which is the current one in this case? Well, it's 7. So it is actually, the logic is correct. What is not correct, or actually, I think it is correct. I think I'm not correct. I think this here that I wrote is not correct. Yeah. In order for us to get this, we would write not 4 but rather 5. Oh my god, let's run that. Alright, let's open Paint and see if that's what we're getting. 4, 5, 6, 7, 33, 8, 9. So this whole time I was just miscalculating this part here. So, oops, no, I don't want to close that. So, okay, we've got that. I think it works fine. Let's test it again. So, let's insert another element, which we will call, let's just call it 9. We want to put it at the second position. Now, how would that look like? Let's try not to mess that up now. We will have, so that would be 0, 1, 2, 3, 4, 5, 6, 7, and we want to change the second position, which is 6. I think it is 6. No, it's not 6. It is actually 1. Because 0, 1 is 2. So we are here in our loop, we are only looping 2 times. That means we're getting 1, 2. That's the loop we're essentially doing here. So that means we're changing 5 in that case. So if we come here, that's where I was wrong in that case here, where I was getting a different result. So the end here would be 4, 9, 5, 6, 7, 33, that's one number, 8, 9. Let's see if that's what we're actually getting. Okay, come here, 4, 9, 5, 6, 7, 33, 8, 9. Great. That means that our insert is finally working, and it was actually working even 10 minutes ago. It was just my bad in this case. However, where is it, the insert? That's correct. That's basically all we're doing. I just spent so much time debugging that crap, and I was actually having it right in the first place, which means that I didn't need to debug it, but that's fine. Here what we could do is just add base cases, like if this is empty, right? If this is empty, then what do we want to do? We want to make, oh, actually what we can do is just say this push val, and when we come into our push function, it will check it if it's empty, which it will be, and we're just making that here. So we are not making any duplicate code. I think that will be it, guys. Yeah, that was quite unexpected actually to take so much time, but I hope that it was somewhat useful to you. And yeah, I mean, if you have any questions, you can just hit me up in the comments. At one point I was just losing it because I wasn't getting the result. It was some live action, but in the end it turned out to be correct. So yeah, thank you guys for watching this far, if you have, and see you on the next video. Bye.